All right, get the full screen. Going to start a problem over here. This is second page of the test. Yeah, sir, I got my coffee. So let's hope I can get through this without making a mistake. I don't do so well talking about these problems anymore and working at the same time. First question is complete the square. All right, and so the first two terms of ax squared plus bx plus c is actually a rectangle. And the rectangle is x times x plus 8. I'm going to make it a little bigger. I always make these too small and then I have trouble showing everything. And so that's my x squared plus 8x. X squared plus 8x minus 3. Well, over here, I can take the longer side, take half of it, right about to there, take half of it off, tack it on to the shorter side and form a square. I'm going to make it big here so I can put everything inside. So that's x plus 4. Now, if I multiply x plus 4 times x plus 4, I actually get x squared plus 8x plus 16. Well, those areas aren't the same. I can make them the same by getting rid of the 16. Now, this has a minus 3 on the left. We put a minus 3 on the right. And now I have a calculation that's the same on the left, that's on the right. No matter what number I plug in, I'm going to get the same answer. I'll put a 1 in, 1 plus 8. 9 times 1 is 9, minus 3 is 6. A 1 gets me a 6. A 1 over here better get me a 6. 1 plus 8 is 9, well, the 16's cancel, and 9 minus 3 is 6. They appear to be the same calculation for any random number, and I just picked a random number. That kind of verifies things. Now, we're not going to be drawing these rectangles like this. So the question is, what happened? Well, it looks like that's been cut in half. Right? This is really the linear term here is plus 0. Right? So I'm really looking at the number between 0 and 8. It's 4. Now, we can do that for any trinomial with the coefficient of 1 for x squared. These are the pictures you can generate. Now, what am I going to do if I don't draw the triangles? I'm going to remember what I was doing. I was cutting 8 in half. Still a positive. And whatever constant I get, I don't care if it's plus or minus, when you square, you're going to get a positive. And that positive is not showing up here. So get rid of it. Bring in the other number, and then you have answered the question. And I'll take this. That shows me you know what you're doing. I don't care if you say minus 16 minus 3 minus 19. Fine, go ahead. If you show me that on a test and you're, trying to do 70 problems in 70 minutes, and then 120 problems in 70 minutes, feel free to leave it like that. And you have communicated to me that you have followed this discussion and know what you're doing. Square root of 40. Well, first couple of days, we looked at 2 times 3 equals 6, something we were sure of. And this 2 is the square root of 4, 3 is the square root of 9, and 6 is the square root of 36. So I know I can rename this as a square root times a square root. And there's all kinds of combinations. There's 2 times 20. There's 3 times 40/3. There's also one that's really nice, and that is 4 times 10. And that's the one we're looking for most quickly and easily. I can tell you one of these has another name that's easier to write. Hope you picked the right one. I hope you say 2 root 10. But if you got that wrong on this test, it's coming again next week. Show me you can get it, and we'll get rid of that gap in your understanding. I'll erase that now. So it's nice if you know your squares. 4, 9, 16, all the way up to 100. Sure nice if you know those, because you calculate with them quite often. Sketch. All right. Well, what I know is in the ax squared plus bx plus c situation, if A is positive, it's cup shape up. If it's negative, it's cup shape down. But if you multiply a negative times something that's producing just positives, you got a tendency to go down. So that's what your shape looks like. I know there's a most important place. Minus B over 2a gets it pretty quickly. Okay. That gets you a 3. Plugging in a 3 gets us the y value that goes with a 3. We have a formula here to find y values that go with certain x values. So let's plug it in and see the negative to positive relationship of the first two terms, and they're going to come at us at a 2-to-1 ratio. 3 squared 9 times -2, -18, plus 3 times 12, 36. There it is. There's the 2-to-1 opposite relationship, -7. You will find that when you add those first two terms, you always either get the opposite of the first term, or you could get that number by dividing the second term by 2, and you can speed up your calculation. Don't forget to put the 7 there. And 18 minus 7 appears to be 11. Yasser's going to correct me anytime I make a mistake. So I'm just going to keep going because then there'll be a correction for everybody. Then I'll edit it. All right, I got to help. So 0. By the way, the tangent, that tangent to the y-intercept is 12x minus 7. So your y-intercept is 0, -7, and I'm on the upswing. And you'll have to look at other videos posted to have that explained. I'm not going to do it every single time. I have explained that in past videos. So I'm moving on. X squared minus 4x equals 5. Did a video yesterday that talked about bringing the terms to one side in y and hoping you can write it as a product. And we can. X minus 5, x plus 1 gets the job done. FOIL it, and you'll see it is that. And if something times something equals 0, then one of those somethings has to be equal to 0. So my answer here on this parentheses is 5. And my answer on that one is -1. So you can't leave it in factored form. This is an equation, and the answers are x equals 5, comma, -1. That's what I want to see on your test. This is another problem I could have done by completing the square. So let's actually do that as well for practice. So let's complete the square. You pause the video on all of these and you can try them. X minus 2 squared minus 4 equals 5. I bring the 4 over, I get 9. I do the square rooting of the squaring process. I get plus minus 3. And minus 2 comes over and I get 2 plus or minus 3. 2 plus 3 is 5, and 2 minus 3 is -1, which is what we got a moment ago. All right, now we're going to write the following as a product. They call that something else. I wonder what they call that, writing sums and differences as product. Oh yeah, factoring. Yeah, that term comes at you a lot. It's nice to know what it means. Write this as a product. So 2x times x, because I got the marker, gets me the first term. Yay. I got to get 5. But remember, whatever you multiply by, there's only 2 choices, 1 or 3. Those get doubled. So this becomes a 2. And what goes with the 3? 3. And this becomes 6. What goes with a 6? 1. And one of those works. They actually both have a combination of 5. So you got to be careful here. And I have a what? Next thing I look at is a minus term. Well, the only way you can get a minus term is a minus and a plus. So one of these has to be plus minus. And I want to get -5. I think I want -6. So I'm going to put the 3 in here. -3 times 2 is -6. -6 plus 1, -5. Now, the only way you get good at this is to practice this. So one of these days, I'm going to come in with just a handout, maybe 50 problems on it, factor, 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 factor. One day we're going to do that. This is that important. You can do it on your own. You don't have to wait for me to bring a sheet. You want to get better scores, go to the internet, look for factoring practice, coefficients other than 1 as well, with the answers, and practice. That's how you get good at anything. So we're going to practice solving an equation now. And not the one that's on the test first. I'm just going to say a destination. Okay, so let's put some numbers in here and see where we end up. Okay, so I'm picking 0. And if I put 0 in, 0 minus 3, the first thing I did is I subtracted. Okay, put a 0 in, -3 squared. I do the squaring, that gets 9. That's the second step. Third step, I do the multiplication. Notice with parentheses and then the harder operations to the easier ones, kind of follows that form. 18 multiplied by 2, and then I subtract 4, cut to the chase, and that takes me to 14, I believe. So I know my destination. But what if I didn't tell you what number made that happen? Well, we'd have to retrace our steps. All right, so like going into the woods. All of a sudden, you're lost. But I know where I am. I'm next to a rock. I wish I knew a little bit more than that to get out of the woods, but I'm next to a rock. How do I get back to the car? Well, I gotta go back. I gotta get back to that tree. I know I took a left there, so now I gotta take a right, so on and so forth. So the last thing I did was subtract 4. So what's the first thing I'm gonna do? I'm gonna add 4. I think I remember seeing the number 18 when we were doing this before. And I think the next thing was multiply by 2. I think I'm going to divide by 2. I remember that evaluation had a 9 in it. Oh, squaring becomes square rooting. And yeah, I don't know any way to get you to remember the plus minus other than to sneak behind you and yell. And I did it to a poor lad who had a concussion one day. So I don't do it anymore. Not a good thing. But he was a soccer kid, and I knew him well, but I didn't know he had a concussion. So we were buddies. He didn't hold it against me. But I'm still holding it against myself. Subtracting 3, adding 3. Oh, 3 minus 3, 0. I think I remember setting x to 0. There was another answer too, 6. Oh yeah, it doesn't matter whether it's a 6 or a 3. 0, okay, I'm going to get 14 out of that. That's true. So now, what was on the test? A 0 was on the test. But can we remember the steps we take to solve an equation to isolate an x? I hope so. I hope you get rid of subtraction of 4. I hope you get rid of multiplication by 2 by dividing by 2. I hope you get rid of squaring, which is plus minus square rooting. And I hope you add 3. 3 plus minus the square root of 2. And I hope you remember that I asked you to memorize a particular decimal that we'll work with to represent the square root of 2. And I hope for my students, they say 1.41. Not all of them are. I hope all of them are doing that at some point. 2x squared equals 9x. That's what the video is all about. 2x squared, 9x. They have something in common, x. So if I let x equal 0, it eats away both sides of the equation, and 0 equals 0. So that's one of my answers. So that basically means I did that. I took out what's common. 2x equals 9. I think one of my other answers is 9 over 2. I think I'm done. Yeah, generally people don't solve it that way. But that's the video I made the other day, so I'm actually seeing it differently. So 2x squared minus 9x equals 0. Take out what's common. X, and if you take out what's common, take 1x out, take 1x out, you got 2x minus 9. And I hope you can see two numbers that work from that perspective. All right. So trying to solve this equation, I've got a vertex, I've got an A multiplier, and I got a height of 51. Wow. Boy, wouldn't it be nice if you could just look at that and write x equals 3 plus or minus the square root of 47 over 2 and be done with it? Boy, that would be nice. Oh, I just did that. Oh, well, how did I get away with doing that? Well, if you know how to put this in graphing form, right? A is the multiplier. I think we could put this in graphing form. 2x minus 3 squared plus 4. And I want that to equal 51. I think I've seen a similar problem just a minute ago. What are we going to do? Well, 4 to 51, right? You got to go up 47 units. Got to go up 47 units. But if I'm multiplying by 2, I only want half of that. Only want half of it. And so I got rid of that. I got rid of that. Now I got to get rid of the squaring. So if I'm squaring a distance, there's half of it. And if I'm squaring that distance, maybe I want to square root it. because then when I double it, I'll go up 47. So I think I want to plus minus square root it. And the final thing I'll do is subtraction of 3 becomes addition of 3. And I guess I got to move this over here. 3 plus minus the square root of 47 halves. All right, and then we can plug it in and see how it works. 2 times 3 plus minus the square root of 47 over 2. I can see that 3's cancel. I know when I square a positive or negative, I get a positive. I know when I square a square root, I get what's inside. I know when I double something that's cut in half, I get the numerator. And I know what 47 plus 4 is. It's 51. Now, I find that far more helpful lots of times than the quadratic formula, which is very cumbersome. Squaring a binomial. Let's let the letter capital A equal x to the 7th and let B equal y to the 5th. There we go. Then this would just be 4a minus 3b squared. What's that? That is 16a squared. Double that product. My answer key was wrong. I mean, where's my coffee? Oh, it's way over there. Minus 24ab plus 9b squared. I wouldn't change the exponents in the middle term. I'm just counting how many ab's I have. And it's minus 24. So now I finish up by saying, I'm going to square x to the 7th. Well, that's x to the 14th. And I'm going to square y to the 5th. Oh, that's y to the 10th. All right, so hopefully you can see that from the get-go. Hopefully you can see the squaring here, the squaring there, and you just got to remember, don't change those exponents. X7, Y5. And all I can do is tell you what it is, not what it is. I think that's what it is. And it's up to you to not say what it isn't. Because when you use an equal sign, you don't want to say 1 plus 2 equals 4. No. And there's an equal sign here, where that binomial can be written the same way as this, that they're equal. So we got another equality here. We want to make sure we don't say something that's not equal. So take out what's common. What do 8 and 10 have in common? 2. What do x to the 4th and x have in common? X. What do y to the 15th and y12 have in common? Y12. Now we got to build it back up. 2 times what is 8? I think 4 gets that job done. X times what is x to the 4th? I think x to the 3 gets that job done. Y to the 12th times what is y to the 15th? I think y to the 3 gets that done. 2 times what is minus 10? I think minus 5. X is already there, so this gets it done. Y to the 12th is already there, so if I multiply that times this, I get that, and I can put that there with, I hope, confidence. Next problem can be done a couple of different ways. Which way is the easiest to do this reduction? Well, when you reduce a fraction, 8/10, you really factor 2 times 4 over 2 times 5, and getting rid of a couple of the factors, because it's multiplication, reduces it. So can I factor the numerator as one method? Yeah. Same thing I did over there. What do 9 and 3 have in common? 3. What do x to the 4th and x squared have in common? X squared. What they don't have in common is the y. So I've got to multiply this. 3 times 3, x squared gets me 9x to the 4th. I got to bring in a y. And 3x squared times what gets me 3x squared? A 1. And now I'm dividing by 3x squared. I think we can see our answer in the parentheses. The other way is to know that when you're dividing into a sum, you've got to divide into both parts. Why? Because dividing by 3x squared is the same thing as multiplying by 1 over 3x squared. And I don't think you would not distribute multiplication with something in a parentheses. Okay, so let's do it that way, but let's go put it back to the original so we can do it from that perspective. How many times does 3 go into 9? 3 times. How many times does x squared fit into x to the fourth? Don't say twice. It fits x squared times. I still have a y there. How many times does 3x squared go into 3x squared? 1, and that's what we had in that parentheses a minute ago. Binomial squaring. We just talked about it 5 minutes ago. I hope you square that number. I hope you square that number. And it's a positive. What do you do with that product, minus 18y? You double it. If you want to keep doing 6 minus 3i times 6 minus 3i, that's okay. It's all right, but it sure would be nice if you look for patterns and use them. Now, what is 9i squared? -9, right? I squared is -1 times 9. And I hope you know what 36 minus 9 is. Didn't say 27 minus 36i. All right, so this was the similar question to what we did a minute ago. And as I say, I've been doing this for years and years and years. I had friends back in the 1800s. And I'm seeing this differently. I'm seeing it geometrically now. So some quick answers come from that. I can see what's common. I can see that is common. That's common. And so if this is a cubic, then so is that. If they're equal, they got to be equal. So I'm missing 2 dimensions, and those 2 dimensions are going to have to be the same value. Well, then I'm looking for 2 things that give me 4, the same number that gives me 4. Well, I'm hoping I see 2 and 2, and I'm hoping I'm seeing -2 and -2. And when I take out what's common, I'm really taking out 0, because if either one of these is 0, we get equality. It's called no picture. Yeah, left side equals the right side. Now, what is the mechanics for that? You get your variables together. You set it to 0. You take out what's common. And you either show that factored form, x times the difference of 2 squares equals 0. And then you don't forget to answer it. X could equal 0, boom, comma, x could equal -2. So I don't want to write x there. Boom, or x could equal +2. Because if you make that dimension, if you put 2 in here, 2 minus 2 is 0, and 0 times anything gets rid of the picture. And 0 equals 0. All right, moving right along. We covered this problem on day 1, and we've been practicing it for 3 weeks. So I hope you just look at it and you say, I'm going to take the square root of 9. Boom. I am going to cube it. Boom. And I am going to flip it. And I hope you get 1/27. Pause the video. All right. Square root, reciprocation, cubing in any order. I decided to do the square root first, which becomes 3. I decided to cube 3, which becomes 27/1. And then the minus sign, I'm reciprocating. Conjugating. 4 plus 7i. 4 plus 7i. 5 times 4 is 20. 5 times 7i is 35i. All over. No middle terms here. 4 times 4 is 16. And minus 7i times 7i is minus 49i squared. But what does minus 49i squared become? Positive 49. And I get 20 plus 35i over 65. Guess I could reduce this, huh? Guess I could take a 5 out of each and say, I don't think I did on the test. I should have. All right, what's that, 13? 21 plus 7i over 13. I got to go back and check somebody's answer, but I think somebody did do that. And I don't remember if I gave credit, so I got to go check their tests again. All right, so what do we have here? We have an answer of 20. I'm going to go with this one right now. And I'm just going to write it underneath the original problem and show you that you could get that much more quickly. All right, so 16 plus 49, 65. And I've got 20 plus 35i. So you look at it, see if you could get that answer more quickly. Could you multiply 5 times 4 is 20? Do you know that it's going to be 4 plus 7i, numerator and denominator? Could you multiply and just change the sign? And 65 is actually 4 squared plus 7 squared. That always happens. So If I wanted to do another one, you can pause the video and try. So of this variety, 7/3 plus or plus 9i. Okay, you wanted to do that, I'm seeing 21 minus 63i, 9 and 81/90. And I'm done. Okay, so you should always look at an answer in the original, see if you can save yourself some work over time. E to the x equals 25. Yeah, just looking at inverse operation, and I know this is a totally new one. The Algebra 2 level, you probably haven't seen the natural logarithm before, so it's totally new. And the inverse operation is logarithm. And that's a button on the calculator. I've asked you to memorize e to the x is approximately, e to the 1.6 is approximately 5. So I could get a decimal approximation here pretty easily because I know 25 is 5 squared. And I know 5 could be written as, I got to do the ln. I know 5 squared could be written as parentheses. E to the 1.6 is the number 5 approximation. And I'm going to square that. And this is looking for exponential activity on top of E. Well, there it is, 1.62. And we have somebody in the class who hasn't seen that too much that got it right. That person will remain nameless, but good job. And I know who you are. So now we're coming over here. We're getting there. Getting there. Takes practice. You want to get good in math, you got to do this early work. 3i to the 19th. I know there's a pattern of 4 in the textbook, but I have always found that writing this as a multiple of I squared brings in a lot more activity that is good for the brain. So I've got 3i squared. That's going to go 9 times I. I have built up I to the 19th from looking at squares because we know what I squared is. I squared is -1. So I'm not looking at this and saying it's odd. I'm looking at that number, which also happens to be odd. I'll do 21 in a minute to show you it's going to be even in a second. Okay? And I think it's important for early algebra students to know if I multiply -1 times -1 times -1 9 times, I'm going to get a negative. I'm going to get 3 times -1 times I. So that answer is -3i. Now what happens if I make this 21? Well, I still have 3. I still have I squared, but now 10 gets me to 20, and one more gets me to 21. Well, now I have 3, -1 10 times I. Well, I think if you do -1 times -1 times -1 an even number of times, you're going to get a positive. While we're on this, why don't we do 22? Okay, so 22 would be 11, and I don't need any kind of single I at the end there. And so I have 3 times -1, 11 times. Well, I hope you say -3. We're going to keep at it till you see it. All right. Distance. Well, I see 9 to 11. That's 2 units of change. 5 to 10 is 5 units of change. So what's that distance? Pythagoras tells me that's 4. Pythagoras tells me he did too. He was a friend of mine. 25. That means that's 29. And I hope you can start doing those in your head. Square root of 29. All right. Average rate of change. I've included this problem at this level because when students came into my calculus classes, they didn't know how to do it. And I didn't want to spend any time on it. I wanted to talk about calculus. This is an Algebra 1 problem. You have a quadratic. You're at -2. -2 gets us 4. And 4 gets us 16. And all I'm asking for average rate of change is the slope of that secant line. That's what we call it. Just the slope. Find slope, got to find the change in y. Instead of saying y2 minus y1, if we're reading left to right, it's a whole lot easier to say, how do you get from 4 to 16? How do you get from -2 to 4? At what rate am I changing? 2 to 1. That's going up at a 2. Every time I go over 1, I'm going up 2. Not the best drawing. So 16 should have been probably up there somewhere. Okay? 2 to 1 rate of change on the average. We've looked at instantaneous rate a lot of other videos. I'm not gonna do that here now. All right, so what's the y-intercept? You plug in 0. And I hope you said 2 to the 0 is 1. And I hope you said 0, 8 for your y-intercept. Okay, that took 20 seconds. The last time we talked about something to the 0 was another 20 seconds. And we'll keep taking 20 seconds until we can get it down to 2 seconds. And you're getting it right, I hope. That's where the repetition's coming in. So, cannot solve this right now unless they're the same base. And I think they have something in common. 8 is 2 to the 3, and 4 is 2 to the 2. Now, we have an extremely important Algebra 1 concept here. And it's on this side. Because the exponent x plus 2 has 2 parts to it. And if I'm multiplying something in 2 parts times a number, I better multiply each part. So this exponent has to equal that side. And it sure looks like x is 4. Almost done. Oh, we got a problem underneath it, didn't see it. So I'm running out of room here. Graphing this. Okay, so let me do this on top of that. So y equals x squared has an inverse, but the inverse is a principal square root, if I'm using the proper term. Because if I do the bottom inverse part, that's not a function. And I'm trying to write this x, y as a function of x. These y values come from plugging in x values here. And so that's really the picture we're looking at for a square root. Okay, now if I isolate that picture, I can see a very important x value. There's tons of x values here. There's one that's most important, and that's 0. The square root of 0, very important. So a square root is the side of a square, and the smallest distance I can make here, up, is 0. So what do I want 3x plus 12 to equal? That. And what's going to make that happen? -4. And if I put -4 in, I get that. And what is that? That. Now, you can pick another random value. I don't care what value you work with, but I hope you pick some square root that's easy to work with. I like 25. Takes me out a ways, and therefore I've got nice approximations once I find that. So the square root of 25 is 5. 5 times 2 is 10, plus 1 is 11, if I pick the right number. So I got to take 12 away. No, I wouldn't do 25 this one time, I wouldn't. So I just randomly pick a number here, and I can see that what's going to be nice. 9. I think the square root of 9 is going to be nice. Okay, so how do I get that easily? -1. So I'll pick -1. -1 times 3, -3 plus 12 is 9, times 2, times the square root of 9 is 6, plus 1 is 7. Okay, now let's actually name that tune based on what we see. I see this, I would write this, and this. So it might be slightly different here. Okay, -4 to -1 is a change of 3 units. So if I put -1, I get the square root of 3 units. And if I go from 1 to 7, I'm going up 6. 6 over root 3. Well, 6 happens to be, do I want to do this? Now, I'm going to stop because it's going to get a little complicated. So I'll stop there. I wanted to show you this returns to a 2. I'm not going to do that. All right, because let's just say I'll do it after I'm done because I've already made a video. I had to make it twice. This is my third because I got to get this uploaded this weekend, and I don't want to start again. So I'll do that on my own. Maybe comment on it on the next one. Coffee. Almost made it through, I think, without a moment like that, a glitch. All right, so a lot of folks had trouble with this. use something as your guide. When you're not sure how to do something, go back to something you're sure of. All right, is there another way to organize that? To say the same relationship, but in a different way? Yeah, 25, 5 squared. So what I'm really doing to get rid of this operation is moving the 5 as a base to the other side. So what am I going to do with the one above us? I'm going to move 1/5 to the other side and make it a base. And I'm going to perform that calculation, 1/25. Last problem. And I hope you're starting to see some patterns here in these equations, these functions. We always seem to do the first two operations. First three, actually, get rid of the addition or subtraction. Get rid of the multiplication or division. Get rid of the major operation. And then worry about what's in the parentheses. That's becoming a pattern. So let's just do it. Do it quickly. Move forward to the other side. Divide by -2. Move the base to the other side. Boom, boom, boom. Add 3. 3 to the 1 is 3. And if I add 3, I should get 6 as an answer. And let's check it. So 6 minus 3, 3. What's the exponent I put on top of a 3 to get a 3? 1. What's 1 times -2? -2 plus 4, +2, and I move on. All right, getting tired here. Just going to shut down and I think I said, my memory's going, but I think I thanked the person who sent the info on the Math Village in Turkey. I can't remember if I said it on a video or not, so I'll say it again. If you could send me more information on that location and what goes on there, I'd appreciate it. So jvollinger@nmhschool.org, in case I forgot to write that down on one of those other videos. And that, if Saladin's still out there looking at any of these, yeah, write to me. I'm happy to chat with you. All right. Toodaloo.